10-16. Here we go. Keep getting these a little bit more gnarly. Yeah, in this case it gives us the hypothesis, so that's why I haven't stated it on here, but 15 says that mu is greater than or equal to 20, and the alternate is that mu is less than 20, so it gives us a random sample of 5. So it results in the following values, which I've put here: 18, 15, 12, 19, 21. Assume a normal population, use the 1.01 significance level. Can we conclude the population mean is less than 20? Hence the alternate hypotheses. Okay, so we've got to do something. First, we do have to find the mean. Okay, so we do that. And then if you look at the formula, and really all we're doing, I think, is finding the standard deviation here. Yeah. Okay, so we're finding the standard deviation in this case, and it's the sample standard deviation. I suppose we could look it up, but so we simply go here. It's equal to our number, minus the mean. Okay. And we carry that on down, right? Then we square that, so just equal to this to the second power, and we carry that on down. Okay. Then we total that, right? Okay, I gotta get to my sum here. There we go. So we sum that. And that gives us 50, right? Okay. But then that's kind of weird. Why did I put that there? I don't want the underline on that. So then what we do, of course, is we want to take the average of this. But, okay, and the reason we don't do that is because it's the average of this minus 1, if that makes sense, right? So our n is 5, but when we're doing a sample, or a standard deviation of a sample, we got to do it n minus 1 to figure out our average here, right? So that's why I did a total. So really what I would say is that I could do this. This is equal to this divided by 4 in that case, right? 5 minus 1 is equal to 12.5. Okay, and then I'm gonna end up getting to this number. I hope that this should be equal to the square root of this one. Square root, okay. And it does. Okay. And here I kind of did it longhand. I did C6 divided by B9, which is my n, minus 1 to the 1/2 power. So, and you can do it either way. Okay. But remember, when you calculate the standard deviation of a sample, you have to take it n minus 1. We have to put in that adjustment factor. So then I list my data just like I do on anything. I'm still using my t formula, right? And it says in A, it does say that I have to, hang on, I got to get to A there. It says state the decision rule. So I'm going to reject t if it is less than a minus 3.747. Okay. And I looked that up because my hypothesis is that mu is less than 20, so I'm going to reject it if it's less than that. How do I find my 3.747? Again, I'm at the significance level. I'm a one-tailed according to the hypothesis. So I'm a one-tailed. That significance level, and my degree of freedom is also n minus 1, or 4. Okay, so one-tail, degree of freedom 4. And significance is way over here, 0.01. Okay, so 3.747. You guys will have to look it up. Yours up in the back of the book, or if you got a chart like that or want to look up a chart like that, that's fine. Okay, so I'm going to reject it if it's less than, okay, minus 3.747. And when we're less than, we go with the minus, because if you think about the normal distribution, we're really looking for an amount that's to the far left, or on the, very much left of the middle, and we show those in negative numbers. Okay, so I've got my x minus my mu, or my mean of x minus my mu, which is 17 minus 20. Where's my 17? There it is. I'm sorry. My sample mean minus my 20. Okay, divided by the standard error of the mean. Okay, and then I'm not going to bore you with the math again because we've done that several times before. But my top part then is minus 3. My standard error of the mean is 1.58. And so then I simply say that it's equal to that one divided by that one. And I get minus 1.89, la da da da. Okay, so is it lower? Okay, minus 1.89 is not lower, it's greater than that. So I cannot reject the null. I cannot say with confidence that the population mean is less than 20. And then it asks me to estimate the p-value. And the p-value, again, we got to go to our chart. Okay, once again, our degrees of freedom is 4, and we're using this t value here that we calculated. So let's say it's 1.9, minus 1.9, or 1.9 is what we're looking for. Okay, so my degrees of freedom, I just kind of come along there and I go, 1.5. Oh, it's less than this one. Okay, but it's greater than this one, so it's going to be in between those. So it's going to be, between 0.05 and 0.10. They do say the standard practice is to take the bigger one of those and say that it's less than 10% then. Okay, that it's less than 10%. And why is that? Okay, I mean, it seems kind of odd that our sample mean was 17 and our mu is 20, but the answer is, in this case, that we've just got such a small sample size, right? That because our sample size is so small, really, that our degrees of freedom, right, from 5 to 4, creates this pretty big t-value. It's a negative. Maybe we'd say it's a pretty small t-value, but a big by that standard, and so it makes it more difficult then to say with confidence that the population mean would be less than 20 in that case. So there you have 10-16.